Hi everyone, it's your favorite earth science teacher, Mr. Jensen. Today I would like to do a quick review of longitude and time. I'm going to try and make it quick because some of my videos are hitting like 15 minutes. Pretty long to watch. So let's check it out. I have Earth Science Reference Table page 5 open. We're going to focus on longitude today. So for example, let's just focus on the middle of the map just so it's easy to literally look at. And let's zoom in a little bit more. I kind of figured out how to get the PDF to look a little nicer. Remember last time it was like super zoomed out and looked all fuzzy. I think today looks a lot nicer. So let's focus on the international date line. That's going to be really important for longitude and time, and the prime meridian, which is all the way to the right. I will put a PM here, and let's see, international date line here. All right, so here's the international date line. I'll try to connect it with the best line I can. Ooh, not too bad, not too bad. All right, and I'll do the prime meridian with the line as well. Pretty bad, not a perfectly straight line. All right, still works for us though. So longitude and time, we have to figure out kind of like the main numbers you want to focus on with longitude and time. So I'm going to zoom out. I'm going to zoom into this part of the map so I have a little space to write. All right, so check this out. It's going to be like over here. So the Earth spins 360 degrees each day. It does that in the course of 24 hours. Whoops. 24 hours. Pen. 24 hours. All right. So you want to figure out what the rotation is per a single hour. So you do 360 degrees, which is what the Earth rotates in one day, divided by 24 hours, which is the time period that it takes to do so. So this means that every 15 degrees of longitude, time changes by 1 hour. 360 divided by 24 is 15. You do top per bottom, so degrees per hour. So you really are working with 15 degrees per hour. So let me zoom out, back to our full map. And most of the questions you're going to get are going to have to do with something being a certain time somewhere and a different time somewhere else. All right, so if I'm at the international date line and we say it is 12 p.m. Oh no, that's too big. We say it is 12 p.m. at the international date line. We want to figure out what it's going to be at, let's see. I'm going to try and do it in even 15s. So let's see. Let's say 150. I'm going to draw a line for 150. So my blue line is now 150. So it's 12 p.m. at 180 degrees, and it is sometime at 150 degrees. We want to figure out what time it is at 150 degrees. So first we want to figure out how many degrees apart are these two places, 180 and 150. So I'm going to write at the top where I have that space. So 180 degrees minus 150 degrees will give me 30 degrees. So we know there's a 30-degree difference between 180 and 150. Then we want to use our magic number here to divide, because we know it's 15 degrees per hour. Right? So I take my 30, my difference in degrees, and I'll divide it by 15 degrees per hour. Now, technically with like math equations, right? I have two matching units, so I can get rid of the degrees, and this will give me the difference in time in hours. So 30 divided by 15 is a 2-hour difference. Right? Then I have to figure out, is it 2 hours ahead in time, or is it 2 hours behind in time? So if I am moving to the east, it gets later in the day. If I am moving to the west, it gets earlier in the day. So because I am moving east in this case, I am going 2 hours ahead in time. So if it's 12 p.m. at 180 degrees, then at 150 degrees, it should be 12, 1, 2. So at 150 degrees, it would be 2 p.m. All right, and there is one example of longitude and time. I'm going to try and keep it quick for a 5-minute video that's more watchable than 15 minutes. All right, thanks for watching.